Rusbeh Yassini Fard and Stuart Schley. The Accidental Network. How a small company sparked a global broadband transformation. The internet humming through your device right now, streaming videos, video calls, instant downloads, is powered by broadband. It's blindingly fast compared to the screeching dial-up connections that once made us wait minutes just to load a single web page. But how did broadband come to be? The story involves intricate timing, multiple players, and bold vision, but none of it would have been possible without one particular invention: the cable modem. This blink tells the story of that invention, not born in Silicon Valley's gleaming campuses, but in a struggling mill town in Massachusetts. A small company with a big idea, fighting to exist in an industry that didn't yet understand what was coming. Get ready to discover how the cable modem helped rewire civilization itself. Electronic beginnings. Rusbeh Yassini Fard grew up in a small town east of Tehran, in Iran. Money was often tight, but he didn't feel poor. And by the age of 14, he was already dismantling and rebuilding electronic equipment, a passion that would shape his entire trajectory. At 18, he made a bold move. He followed his older brother to America, 3 years after his sibling had relocated with an American fiancée. This wasn't a temporary adventure. It was a full commitment to the American dream. West Virginia University became his proving ground, where that childhood fascination with electronics transformed into serious expertise. After graduation, General Electric offered him a position. The circumstances weren't exactly glamorous. The company had apparently fallen short on diversity quotas, but he didn't care about the circumstances. What mattered was the opportunity. His modest salary came with an invaluable perk: access to living legends in the television industry. He absorbed everything he could about how TVs worked, how they were manufactured, and how businesses operated in this cutting-edge field. But by the mid-1980s, GE was losing ground to nimble Asian manufacturers. The company's response proved instructive, though not in the way leadership intended. They started cutting experienced engineers while bringing in MBA graduates to execute a turnaround strategy. The approach failed spectacularly, and GE eventually sold the division. Many would have viewed this corporate collapse as a setback, but Yassini Fard watched carefully, taking mental notes on what not to do. It would come to help him down the line. The boom of cable. The early 1980s brought a strange new energy to American living rooms. Suddenly, there was MTV with its endless music videos, and Nickelodeon entertaining kids around the clock. These quirky channels were multiplying fast, and they all owed their existence to something most people never thought about: coaxial cable. Here's what made it revolutionary. Take a copper wire, wrap it in a metal casing, and leave a gap between them. That gap becomes a conduit for high-frequency signals, far more information than those rabbit-ear antennas perched atop old television sets could ever handle. Cable television had arrived, and America couldn't get enough. The growth was staggering. Early 1980 saw 15 million homes with cable. 5 years later, over 35 million. 1 in 3 American households. The industry was printing money. By 1984, Yassini Fard found himself working on GE's ComBand project, where engineers faced a thorny problem. Cable systems were running out of room. Each television channel consumed 6 megahertz of radio frequency space, a requirement the Federal Communications Commission had mandated back in 1952, when nobody imagined dozens of channels competing for bandwidth. The ComBand team's answer was digital signal processing, or DSP. The idea was to convert analog signals into digital form, where they could be squeezed and manipulated in ways analog never could. To pull this off, they needed to create a new integrated circuit, a specialized chip that could handle the conversion. As Yassine Fard immersed himself in the technical challenges, something deeper began stirring. There was something more about this than just fitting more TV channels into cable systems. Something much bigger, but something he couldn't quite name yet. The dream of connectivity. In 1987, the vision crystallized. Yassine Fard saw something nobody else was seeing. A city-wide network where ordinary people could connect and share information instantly. Not just offices or universities. Everyone. A global village made real through technology. The ingredients for this vision had been gathering for years. At GE, he'd mastered the intricacies of cable television, those coaxial lines running into millions of homes. Then, in fall 1986, he joined Proteon, where he discovered the second piece, local area networks, or LANs. These systems zipped information between office computers at breathtaking speeds, but they only worked within buildings. Yassine Fard asked himself, what if you could marry cable television's reach with LAN's speed? By the time he landed at Applitech, a growing data networking company in Wakefield, Massachusetts, Yassine Fard's abstract vision had sharpened into something concrete. He was going to build a cable modem, MO for modulation, DEM for demodulation. The device would attach data to radio waves and then peel it back off again, but do it over the cable infrastructure already snaking through neighborhoods. He shared his vision with a small, tight-knit team. 3 requirements would define success. First, he'd need a chip capable of both data networking and digital signal processing. Second, a media access control, or MAC, protocol. Basically, traffic rules telling bits of data how to navigate the network without crashing into each other. Third, the whole thing couldn't be massive, noisy, or prohibitively expensive. For now, though, he and his team would work with what hardware Applitech had, the NI-10E. This beast weighed 80 pounds, required multiple cooling fans that roared as they whirled, and looked nothing like a consumer product. But it could, theoretically, do the job. Yassine Fard called it his first cable modem. It was far from ideal, but it was a start. The dream was taking physical form. The birth of LAN City. By December 1988, Applitech was circling the drain. Annual revenue had crashed from $12 million to under $2 million. Most people would have run, but Yassine Fard made an offer to buy the company. The board accepted in June 1990. Yassine Fard renamed his company LAN City, and suddenly he wasn't just an engineer with a vision. He was a CEO with a struggling company and a product that barely worked. Reality hit fast. Rock Island Arsenal, their biggest customer, had a crisis. This U.S. military facility sits on the Mississippi River, and flooding had compromised their cable network somewhere. But where? The system was sprawling, and they had no way to pinpoint the failure. 3 weeks of frantic troubleshooting later, LAN City fixed it. More importantly, the company had learned something crucial. Its modems needed built-in diagnostics that could detect and locate problems before catastrophe struck. Reactive problem-solving wouldn't cut it. Then came the technical challenges. The company developed QPSK, Quadrature Phase Key Shifting, a signal modulation technique that could handle the messy realities of real-world installations. Noisy data paths and signal leakage from poorly wired homes were everyday obstacles that would kill the product if left unsolved. For their second-generation modem, Land City chose a hybrid digital-analog architecture. The advantage? No more endless tweaking of analog circuit boards. But here was another fundamental challenge. This new modem had to be small enough to fit in someone's living room and robust enough to function in a citywide network, with data flying everywhere at once. The 80-pound NI-10E clearly wasn't the answer. The team knew what they needed to build. They had the technical roadmap. There was just one problem. Land City was broke. A new modem. Land City was toiling constantly to make ends meet, but in February 1992, it reached a deal with Digital Equipment Corporation, DEC, a computer industry giant based in Maynard, Massachusetts. DEC would make 7 payments. The first for $626,000, then 6 more tied to hitting strict technical milestones. Miss a milestone, lose the money. But nail them all? Land City could finally build its second-generation modem and make cable broadband real. The technical centerpiece was a new protocol called Unilink 2. This was the traffic control system for the company's vision. Intelligent enough to treat different users and applications differently based on network conditions, demand levels, and bandwidth competition. Streaming video needed different handling than email. The protocol had to know the difference. Then came the silicon chip problem. Custom integrated circuits were needed, and that meant finding someone who could code at an elite level. Enter Kurt Beatty, a cocky, cowboy boot-wearing programmer who charged $1,500 per day, outrageous money in the early 90s. But Beatty was worth every penny. Most coders manage 300 lines per day, typically riddled with bugs. Beatty cranked out 1,500 lines in a single day. Flawless code, 0 errors. You don't negotiate with people like that. You just pay them. December 1992, Federal Express delivered Land City's first batch of custom chips. The team held their breath for the most basic test. Could these chips even handle electrical current without frying? They could. Then came the real tests, one after another. Each one passed. The job was done. The second-generation modem worked. Cable broadband wasn't just theory anymore. It was silicon and circuits, humming with electricity, ready to connect the world. The finish line was finally visible. Going digital. The Cable Act of 1992 slammed cable TV providers hard, hitting them with new price regulations in a bid to protect customers. The problem? Cable companies were highly leveraged, buried in debt from their explosive growth. Suddenly, they were scrambling to plug revenue holes while keeping investors calm. But regulation wasn't their only worry. There was another threat coming from outer space. Literally. DirecTV was launching satellites that would beam television directly to people's homes, bypassing cable infrastructure entirely. DirecTV made a brilliant move. It embraced video compression using MPEG standards, specifications from the Motion Picture Experts Group. With compression, it could deliver multiple channels using the bandwidth that previously carried just one analog channel. It was devastatingly efficient. The cable industry had no choice but to follow. It adopted digital compression too, cramming more channels into systems. It also introduced bidirectional signaling, hoping to offer interactive services to keep customers enticed. Then came a real game changer. Fiber optics, transmitting data using light instead of electrical signals. Here's why it mattered. Light doesn't degrade like radio waves do. Traditional cable systems needed amplifiers to boost weakening signals, sometimes up to 50 in a chain. Each amplifier added noise to the signal, and presented a potential failure point. The cable industry's idea was to use fiber optics to push data to neighborhood nodes, then let the existing coaxial cables handle the final stretch to individual homes. Suddenly, you could eliminate dozens of amplifiers per neighborhood, cutting signal noise dramatically. For Land City, watching all this unfold, the implications were enormous. The cable industry was upgrading its infrastructure in exactly the ways that would make cable broadband possible. The pieces were falling into place. Feeding the masses. While cable companies fought regulatory battles, something else was quietly brewing. Home computers were slowly spreading. In 1989, only 15% of American households owned one. By 1993, that number had climbed to 23%. More people wanted to connect to this emerging online world, but the experience was miserable. Computers cost a fortune, and dial-up connections moved at a glacial pace. Land City was proving there was a better way. In 1994, Boston College pulled off something remarkable. 6,500 dorm rooms, all connected to high-speed internet, using Land City's cable modems. It was their largest test yet, and it worked beautifully. But the real prize was still ahead, a personal modem that everyday consumers could actually afford and use. The engineering challenges were brutal. Land City had to slash the price from $5,000 to $499. It also had to eliminate the cooling fan, which meant solving the heat problem without making the unit sound like a jet engine in someone's living room. The solutions came together piece by piece. A new silicon chip with 155,000 gates, massive processing power in a tiny space. A fully digital architecture, abandoning the hybrid approach of their second-generation modem. And a stroke of design genius, protruding metal fins that dissipated heat passively. No fan required. Meanwhile, the industry was waking up to the possibilities. Major cable providers like Viacom and TCI were installing modems in carefully selected, friendly households, mostly employees who wouldn't complain if things went sideways. Overseas, London's Telewest and Amsterdam 2000 were already championing Land City technology. The technology worked. The infrastructure was upgrading. Consumer appetite was growing. The broadband revolution was no longer coming. It was here, ready to detonate. Land City's legacy. By 1995, Land City was hitting its stride. Annual revenue reached $6 million, mostly from second-generation modem sales, though its residential model was starting to gain traction. The dream was working. Then the floor dropped out. DEC, Land City's strategic partner, which had pumped in $2.5 million, was hemorrhaging money. It cut Land City loose. But the rest of the business world was finally paying attention. U.S. Robotics swooped in with a $40 million offer. Yassine Fard turned it down. Then came Bay Networks, a Silicon Valley tech firm, with $59 million on the table. Yassine Fard hesitated. This was his company, his vision made real. But his team had a different perspective. They'd sacrificed everything: nights, weekends, family time, pouring themselves into Land City. Now they needed to think about mortgages, kids' college funds, their futures. They needed him to take the deal. In September 1996, Yassine Fard signed it. But Yassine Fard's story wasn't over. 6 months later, in March 1997, the International Telecommunications Union adopted DOCSIS, an official standard MAC protocol. The specification drew from multiple existing systems, including Land City's Unilink 2, which dominated the performance benchmarks across category after category. Cable Labs, the organization behind DOCSIS, invited Yassine Fard to join as an executive consultant. He accepted, continuing to shape the technology he'd pioneered. Fast forward to 2024. DOCSIS is now at version 4.0, supporting data transmission speeds approaching 10 gigabits per second. Land City, the company, may have disappeared into corporate acquisitions, but its DNA runs through every cable modem humming in living rooms across the planet. The legacy isn't just alive, it's everywhere. The main takeaway of this blink to The Accidental Network by Roozbeh Yassine Fard and Stuart Schley is that the cable modem played a pivotal role in unlocking the broadband revolution. Yassine Fard and his company Land City saw what others missed, that coaxial cables designed for TV could carry high-speed data to millions of homes. Through relentless innovation, his team transformed an 80-pound prototype into an affordable consumer device, overcoming technical obstacles like heat dissipation, signal noise, and bandwidth management. Despite near bankruptcy and skeptical investors, they proved cable broadband could work at scale. When the company was sold in 1996, its technology became foundational for DOCSIS standards that now underline internet connectivity worldwide. What began as a struggling startup's audacious vision became the invisible infrastructure of modern digital life. Okay, that's it for this blink. We hope you enjoyed it. If you can, please take the time to leave us a rating. We always appreciate your feedback. See you in the next blink.